Hi everyone, welcome back to SALTGATOR. Today, we're going to cover a very practical topic, common mold issues you might face and how to fix them. The first issue is mold heat resistance. If your mold can't handle the heat, it may deform, soften, or even melt. The cavity edges can collapse, or you might see heavy flashing. This usually happens because common 3D printing materials like PLA or PETG have low heat resistance. To fix this, switch to high-temp materials like high-temp resin, PA12, PK, or PI. If you're limited to PLA or PETG, then increase the wall thickness. 3-5 millimeters with 5 to 7 layers at the top, and at least 3 millimeters at the base. This helps the mold resist pressure from clamps or screws without deforming. The second issue is mold strength and sealing. If the mold isn't strong enough, you'll get leaks, cracks, or even broken edges when clamping. After demolding, you might also see mold damage or leftover material that's hard to clean. This happens because 3D printed molds have weak points between layers, and injection pressure can exceed the material's strength. To fix it, increase the wall thickness to at least 3 millimeters and switch to a screw locking design instead of hand clamps. This greatly improves strength and sealing. The third issue is rough mold surfaces, which cause demolding problems. This often leaves print lines on your part and can even cause tearing or stringing. This usually happens with FDM prints, which have rough surfaces, or with sticky materials like ABS, PC, or PVC that bond too strongly with soft gels. To fix it, sand the mold surface after printing, apply a non-stick coating, or use release agents like silicone oil or Teflon dry film. For the best results, switch to SLA or DLP resin printing, which gives you a much smoother surface. From our own tests, PETG and PA molds perform the best because they don't bond too strongly with soft gels. The last issue is poor venting design. If your mold can't release trapped air, you'll end up with bubbles, burn marks, or incomplete filling. This happens because most 3D printed molds aren't designed with venting in mind, so air gets trapped inside. To fix it, add vent channels at the parting line, ideally 0.2 millimeter deep and 5 millimeters wide. You can also design removable vent pins or open vent passages. Another option is to increase holding pressure and time, and keep the injection paths short to avoid dead zones where air might get trapped. I hope these tips help you better understand mold issues and avoid common mistakes in your projects. Keep experimenting and improving. You'll be able to create cleaner, more polished results every time. See you next time.